All right, we should be starting a new video today for 5.5b. And up until this point in time, we really only ended up solving either a singular trig function or we have solved possibly two different trig functions at the same time. What we're going to really be working on today and some goals that are going to be our focus today are going to be using things that involve possibly substitution, where we might have to substitute another identity in for something else. We will also consider things like factoring. That's going to be a very big piece of this. And some other miscellaneous ideas of helping you solve for different values when it comes to these trig functions. So we'll see some other concepts that'll come up in this particular video. So kind of make notes of some of the larger basic ideas that are going to be going on. Now, as I start out with like this very first one right here, this is a very easy question to end up missing a very simple concept that's at the beginning of it. First off, you definitely at first glance of it, you look at it and you see a factoring question. And I would not disagree with that the overall pattern of this looks like it is a factoring concept. But I want to point out two main things that make the factoring part really not helpful. And that is the fact that this is a cosine and a sine. They are not the same variables that are listed inside there. So ultimately, factoring would be a very difficult concept at this spot. So what we're going to do right here is we're going to keep this 2 on the outside, but we're going to substitute this cosine squared for something else that would work it much better, and that would be 1 minus sine squared theta, or sine squared x. And then I'm going to subtract minus sine x from this, minus 1, and set it equal to 0. Now, that is the biggest note here, is that if you're going to use any kinds of factoring techniques or any of these kind of techniques, you're going to want to have the same kind of function relationship. You can't solve it any other way. Now, distribution here would lead us to 2 minus 2 sine squared x minus sine x minus 1 is equal to 0. We're just going to combine some like terms. And ultimately, at the same time, I do not like having negatives in front of my squared term, specifically when I'm trying to find an actual factoring technique. So I am going to combine these to be a positive 1, but then I'm going to run a negative through the whole thing, which would make it 2 sine squared x plus sine x. And since that was a positive 1, it would be a minus 1 in terms of the end result. Now, this particular question now is factorable. And I'm going to go straight to some factoring techniques here. So 2 sine x in one and sine x in the other. I'm going to use that technique of guess and check again. I need to find a positive 1 in here and a negative. So one of these is positive, one of them is negative. So I'm going to make the this one, the 1 times 2 sine x is going to be 2 sine x, and this one will be the minus variety. And now I've got it set equal to 0 and can solve for the individual values, where sine x is equal to 1/2, not a positive 1/2, and where sine x is equal to negative 1. Now, each one of these deserves its own solving situation. When is sine x equal to negative 1? That's at 3 pi over 2. And when is sine x equal to positive 1/2? And that's at 5 pi over 6 and 5 pi over 6. And if you think about those ones carefully, pi over 6 here, 5 pi over 6 there, and 3 pi over 2 there, ooh, that's one of those 2/3 variations. So we would go that x is equal to pi over 6 plus 2 pi over 3k, and that would be your solution to that. Now, all the rest of the stuff that's in the latter part of it is really not the most important or stringent thing. We've seen this before. It's this substitution right here that was really the new component to it. So nothing really exciting. It's just the fact that we need to make sure that the variables, or the functions in this case, match each other. Now, we do have other substitutions that we'll see here in the future too as well. Like that's a cosine double angle. Don't get it confused with a cosine squared. And you really, at this point in time, and you're like, oh man, the whole thing needs to be about cosine, it would probably make sense to pick the correct cosine double angle formula to make this guy fit. And I think that the best one to choose would be 2 cosine squared x minus 1, then plus the 4 cosine x plus 1, and set that equal to 0. 1's will cancel, and I'll end up with 2 cosine squared x plus 4 cosine x is equal to 0. That actually is a GCF kind of question where you could pull things out. 2 cosine of x is times cosine of x plus 2, yes. Set that equal to 0. And if I set it up and solve, ultimately if I set this equal to 0, I'm really going to end up with cosine of x is equal to 0. And this one would be cosine of x is equal to negative 2. Now, solving, when it's cosine 0, that would be at pi over 2 and 3 pi over 2. That doesn't seem like it's a big deal. This one did generate an actual outside the realm idea. We haven't seen one of those in a while. There is no way for the inverse of cosine to be negative 2. It has to stay within the restricted values of 1 and negative 1. So that is a no solution concept. You like my sound effects? It's real good. In that case, then, it would be x is equal to pi over 2 plus pi k, so that we could generate these answers that are listed from the first part. So it is reasonable that you might run into extraneous solutions. We've heard about that in the past. And when substitutions happen like that, they tend to sometimes make those kind of situations happen. Now, in number 3, we're definitely dealing with a sine squared or a cosine squared. And at first glance here, it really actually does not matter which one of these you change to match the other. I'm going to change the cosine squared to start out with. 3 sine squared x is equal to 1 minus sine squared x. And if I subtracted, I'd end up with 3 sine x. No, not 3 sine x, 2 sine x. 2 sine squared x, excuse me. 2 sine squared x would be equal to 1. Well, that's not going to work right. If I added it, wow, I'm really messing that one up. Let's figure that part out again. If I added it to the other side, I'd end up with 4 sine squared x, sorry about that, is equal to 1. If I divide by 4, I'd get sine squared x is equal to a fourth. And this right here, you need to be careful of that the solving technique that you're going to be searching for here is going to, and you know what, I really don't even like setting it up that way where we solve with radicals. I would probably move the 1 to the other side and go 4 sine squared x minus 1 is equal to 0. And solve it with a difference of squares. It shouldn't technically matter. 2 sine x plus 1 and 2 sine x minus 1. Sine x minus 1. Sorry, it's late on Friday and it's taken a lot to get these. So when is sine x equal to negative 1/2? And when is sine x equal to positive 1/2? And I would have gotten the same thing here if I'd had done the sine squared x is equal to a fourth and then taken the square root of each side, and I would have gotten 1/2, but keep in mind you'd get a plus or minus in that case. So it doesn't mean that you can't use square roots, just be careful as you do them, okay? Now, that question will definitely yield some answers. They're all going to be sine is 1, 2, 3, so ultimately pi over 3 answers. And those pi over 3 answers would be, no, they're not pi over, sine is 1, 2, 3. So, oh, it's pi over 6 answers. So you got all the pi over 6s. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay? And all of those answers would be acceptable. Now, up here at the beginning, my original train of thought was to substitute for the cosine squared. You could just as easily on this one substitute for the sine squared and write it as 3 times 1 minus cosine squared x time is equal to cosine squared x. And a little distribution would give us 3 minus 3 cosine squared x is equal to cosine squared x. A little subtraction again and solving, and we'd end up with, I'm going to add it to the other side. Just makes more sense to me because it's a 4. So 4 cosine squared x is equal to 3. You could move the 3 over here by subtraction and set it equal to 0. And again, you could factor that question, or it doesn't work as well as a factoring question. You would really want to solve that one with the square root. So because this is not a difference of squares like it one was up above, so I'm going to put that 3 back where I had it. And I would solve by dividing by 4. That takes care of this. And then take the square root. Now, once you take the square root of this and both sides, you would end up generating that cosine of x is equal to plus or minus the square root of 3 over 2. And that is going to give you the same pi over 6 answers that you got when you did it the other way. So as long as your substitution is valid, there's no real reason why you can't come up with a solution there. The only ones I would be cautious of is when they're doing a double angle, like number 4 or number 2. Not so much number 4. There's only one way to go with this. That's 2 sine x cosine x, because that's the only identity that works for double angle for sine, minus sine x. And that question will work itself out relatively easily. It's the one that was above that had a double angle for cosine, and you got to be really thoughtful about which ones you plug in so that you get the right idea. So if I add that to the other side, 2 sine x cosine x plus sine x is equal to 0. And then I'd take a sine x out, and I'd be left with 2 cosine x plus 1 is set equal to 0. And then you're solving two situations where sine x is 0 and where cosine of x is equal to negative 1/2. And you'll end up generating two separate answers to this, and that's going to be that sine is 0 at 0 and pi, and cosine is negative 1/2. Cosine's 321, so it must be a pi over 3 answer in all students take calculus, and that would mean that it's in the second and in the third quadrant, and that would be 2 pi over 3 and 4 pi over 3. And then you'd write your all solutions in that regard, okay? So be thoughtful, think about things, get the right substitution, and that's what that whole page is really basically teaching you, is that there are terms that you'll see along the way that need to be written a different way so that you can continue with the solving technique. So substituting an identity, you got it. It's not that big of a deal, okay? Now, there are a couple of other miscellaneous techniques that you need to be aware of. This one doesn't happen very often. Sometimes you need to square both sides. I've actually, in all my career, only seen this done either one or two ways. That's the sine squared plus cosine squared, or it can be a subtraction as well too. But when you square both sides, you square it like as such, okay? Keep in mind, yeah, sure, one side turns into 1, but the other side, you just don't distribute the square, and that would be 1 would equal 1. That doesn't work. You have to FOIL this. So you'd end up with something like sine squared x. The inside-outside would be plus 2 sine x cosine x, and then plus cosine squared x at the end. Now, this sine squared and cosine squared that you fundamentally saw right at the beginning does turn into the number 1, and subtracted on the other side would give you 0, and ultimately you'd be dealing with 2 sine x cosine x is equal to 0. I hate that color. I'm going to get rid of that. And you would solve in that regard. Now, you could think of this as like a double angle. Doesn't really make any difference. Or you could solve each one of them individually. This is really sine double angle. And when is sine double angle going to be equal to 0? Well, sine double angle is going to be equal to 0 the same place the regular angle is. And that would happen at 0 and at pi. No. I'm thinking about that. When is this going to turn to 0? I don't like looking at it as a double angle. I'm going to think about this guy as solving each one of them. You divide by 2, you really are basically dealing with sine x cosine x is equal to 0 still. And when is each one of them going to turn to 0? Well, sine turns to 0 at sine is 0 at 0 in pi. I have to think about these in my brain sometimes. Or it could be this one turns to 0, and that would be pi over 2 and 3 pi over 2. And an all solution case for this would be from 0 plus pi over 2k. And that would be the answer that we're looking at here. So kind of be thoughtful about that. As I thought about this question a little bit more, I'm a little nervous about stating that every single one of these answers is going to actually work in that original question. And most of the time when you square both sides like this, you're going to get stuck in a situation where you need to take the answers and you need to check them with the original to see when they would work and when they would not. Now you have to check each one individually and see whether or not those answers are true or false. And if I plugged sine x is 0 and cosine of sine of 0 and cosine of 0, would it generate the number 1? Well, sine of 0 is 1 and cosine of 0, or no, sine of 0 is 0 and cosine of 0 is 1. So this would be a valid solution. You'd be able to take this one for sure. Pi, sine of pi is 0, cosine of pi is negative 1. And so this answer would be invalid. So we're taking a look at ones that would be extraneous possibilities. So be careful. When you square both sides, check it. That's the deal here. I think there's probably another one in here that's extraneous too. Pi over 2, sine of pi over 2 is 1, but cosine of pi over 2 is 0. So this answer would be valid. And I bet you $100 that one's not. Okay? So big deals there. Check your answers carefully when you're squaring both sides. Now, this does not happen very often. This is an extremely arbitrary case. I rarely use this one. It's just one of those ones that could be a possibility. Okay. Sometimes you may need to actually factor it, but then when the factoring gets down to it, you might have to use your calculator to check the actual angles. There is no way I'm going to see it straight out of the gate. I'm going to do a front times back. That's 12. It's got to add to 8, so the answers must be 6 and 2. And I'm just going to solve a little bit easier question. That's 4x squared plus 6x plus 2x plus 3. I'm just doing a grouping technique. Taking out a 2x out of this, I'd end up with 2x plus 3. And if I took out a 1 out of the other one, I'd end up with a 2x plus 3. So ultimately, my answer would be 2 tangent of x plus 1, that's one of the factors, and the other factor is 2 tangent of x plus 3. And you're probably going to note that both of those individual answers are not usually ones that we would see on the unit circle. So we're taking a look here. When is tangent of x going to equal negative 1/2? And when is tangent of x going to equal negative 3/2? Now, even though this is 1.5, it's still okay because it's tangent, and tangent doesn't have the restrictions on its range like sine and cosine does. So this is going to be a valid solution. You're going to be okay. But ultimately, we would have to go to our calculator to generate these answers. Now remember that if we do the inverse tan, we're only going to see answers that are in the first and the fourth quadrant. And those won't be the full entire ones that we need in each individual case. So let's be thoughtful of that, and at the same time thinking about ASTC in each one of the individual cases. So if I take the inverse tan of negative 1/2, let's see what we get here, inverse tangent of negative 0.5, I'm going to get an answer that's going to be in the fourth quadrant. And that makes sense that it's going to be down there. You could write that one as its completed value. So let's think about it as its positive route. So I'm going to add 2 pi to this. And ultimately, I'll get an answer of 5.882 or something like that. 5.82. Now, that's the one that's in the fourth quadrant. Now, that does not mean that that's the only one that's viable. The other negative location for tan could be in the second quadrant, and I would want to use this reference angle away from pi to figure out what that is. So I'm going to go pi plus this reference angle that was given here. Since it's negative, it'll put it in the second quadrant. And the other answer would be 2.6 is what I think that said. Sorry, it disappeared so fast. 2.68 is what the other answer is. And each one of those answers are within pi distance of each other. So really the all solution for this one is plus pi k. That'll generate this other one. Now that's only half the problem. The other half would be taking a look at the inverse tangent of the other side, which is the inverse tan of negative 1.5. And again, this is going to give me an answer that's in the fourth quadrant again. Let's find out what its positive partner name would be, plus 2 pi added on to that so that we can get it in the right spot. 5.3 sounds like a decent answer, 5.3. And the other one, as we've done in the past on that one, is in the second quadrant again because it's negative. So I'm going to use that reference angle as a secondary choice, and pi plus this reference angle will give me an answer that's in the second quadrant, or 2.16. 2.16 plus pi k is going to generate that answer too as well. All right? So it has 4 answers. Wow. Totally reasonable. It could happen that way. So don't be surprised by that. Factoring, but you might have to use your calculator to get the inverses. Now go back on that question if you have to and recycle the words that were going on in that one, because it's well worth understanding where the angles are actually drawn at, okay? Now, here it comes, number 7. You're probably like, well, okay, that factoring one wasn't fun, but it was factorable. But what if it does not factor at all? Now, this is your worst possible nightmare kind of question. I know you guys are like, oh, no. Quadratic formula. Yes. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And, yeah, that's totally a reasonable idea that the factoring won't work, and you have to come up with another plan. Front times back of this is negative 6, and the bottom is 2. There is no factors that will make that job work. And so what you really want to do here is solve a simpler problem, and that's going to be with the quadratic formula. I know it's simpler. But instead of saying that it's about x equaling the actual quadratic formula, it's cosine of x. Now, this is a very important thing to note. You're used to saying that this is equal to x, but you've got to remember that it's got to be the function that you're actually talking about, x. And ultimately will mean that you might have to involve using an inverse. So let's see what the values are going to end up giving me. I don't know why I just drew a big field there. So negative of 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 2 divided by 2 times 3. And I'm still dealing with cosine of x is equal to this. And we're really going to end up with 2 possible solutions that we need to check. And that's going to be negative 2 plus or minus. Now remember that that's really 2 concepts there. The square root of, that's going to be positive 24 added to 4 is 28, I believe. Positive 28. Let me check my work there. Make sure I'm right there. 4, negative 12, positive 24. It's going to be 28 is what's going on there. And it would possibly be reducible. I'm just going to reduce it a little bit here too as well. Because that is another name for that is 2 square root 7. And if I divide everything by 2, I'd get negative 1 plus or minus square root 7 divided by 3. And that is going to be the 2 solutions that we really need to take a look at. Now, these do not represent the actual radian answers yet. What they do represent is the number in which you have to take the inverse cosine of. So you really have 2 separate problems that you need to figure out. And that's going to be, what is the inverse if I do the plus 1? Let's do the plus 1 first. So I'm really dealing with cosine of x is equal to, and I'm going to just grab my calculator and get a value for negative 1 plus the square root of 7. and then take that answer and divide by 2. And I'm really trying to figure out what's the inverse of 0.82. Now, this is on your calculator, so it's probably useful to leave it right here for just a second and take the inverse cosine of that answer. And see, this is the radian value that you want. Sorry, it disappeared there. 0.604. Okay? 0.604 is one of the possible choices that you need. Did I divide that right? Let me check. Oh, I divided it by 2. Darn it. Let me figure that out again. I have to erase these two. Sorry, I made a mistake. -1 plus the square root of 7. I was supposed to divide it by 3. Sorry, guys. And then, so let's make an adjustment. That's 0.55. So this is 0.55. Easy mistake. 0.55. And if I take the inverse cosine of that answer, of this, I will get 0.99. All right, that's the one I'm looking for. 0.99 radians. Okay. Now you're like, okay, that's one of them, except that his partner also needs to be taken care of because that original guy was positive, and the inverse cosine thought it was in the first quadrant. But ASTC says that it could also end up being in the fourth quadrant, and that fourth quadrant answer would be this reference angle subtracted from 2 pi, or 2 pi minus 0.99, and let's see what that number is for the other answer. You're like, wow, there's a lot of little pieces to this, and you're absolutely right. They definitely have you thinking about things that are necessary. So 5.29 is the other answer. 5.29 is the other. Now I'm going to box these up. Now that was only just from the positive deal. If I go back over here and do the subtraction one, because that was plus or minus, I need to find out what that cosine of x turned out to be. And maybe it might generate answers, and maybe it might not. So let's see what we got. -1 minus the square root of 7. But then I'm going to divide that answer by 3, which I did right this time. And it says the answer is -1.21. Now, unfortunately, this will not generate an inverse to it because it's outside of the realm of what cosine expects between 1 and -1, and that is an extraneous answer. And it's not going to generate any 2. The other one is going to definitely generate the 2 answers that you're searching for, and those are both plus pi k, or 2 pi k is what they should be. Okay? Now, that had a lot to it. Okay? Don't beat yourself up. You want to try one on your own if you want to give this a good shot at it. So I'm going to pause the video for a couple of seconds. You try it out. You pause it too, and see whether or not you can generate the answers that are necessary there. Now I will get a certain distance into it, and then I will pick up from that point so that you guys can see what the final answers are. Now what we've got going on here happens to be that I plugged it in into the quadratic formula and evaluated it based on what the values are, expanded made that 6 root 2, and then I reduced it. So we've ultimately got a plus or minus situation of each of the 2 individual cases. So I've got a plus one that I need to find out and the minus one that I need to figure out and see if they actually work. Now remember, they're equal to sine x. It's a really easy thing to do that when you run to your calculator and you start calculating this concept of what the quadratic formula is telling you, to forget that you really need to take the inverse sine of it when you get going. So I'm talking about sine x equaling a specific decimal. So let's keep that in mind. We're dealing with -2 plus 3 square root of 2. And then I'm going to take that answer and I'm going to divide it by 7. And that answer is viable. That is definitely between 1 and -1. So I'm dealing with 0.32, and your piece of paper is really acting like I'm keeping track of my brain. Now, if I take the inverse sine of that, I'm only going to generate an answer that's in the first quadrant. So this answer that you get as far as its radians, negative or 0.326, is only going to be the first answer that's in quadrant 1, 326. Now that's a radian now, even though it looks a lot like the original one. This is the radian because I took the inverse. It just happens they look the same. Okay, this is a quadrant 1 answer, but based on ASTC, that's not the only place it can actually occur. It can also occur in the second. And since this is a reference angle in the first quadrant, the second one is going to end up having the same reference angle down here, so I would subtract it from pi. And if I go to my calculator and figure that out, I'd go pi minus this amount that's right here, which is the reference angle. I'd get the other one, which is 2.81. Okay? Awesome. You've got your two answers started out with. Now, that's two of them. Second one would be to look at what does this thing happen if I put a subtraction sign on the inside. Let's see what it does. -2 minus, now in the previous one, it actually made it so that it was an answer that was extraneous. And you're probably going, it's going to be extraneous again, G. And the answer is, no, it's not. It actually can turn out that these sine x, that these quadratic ones can actually generate 4 answers. Is totally possible, or -0.89 is what I've got going there. Now remember that that answer that I'm looking for, that is not the actual, what do I want to say, not the actual radian. This is just the answer to the negative of the quadratic formula. So you need to take the inverse sine of that answer, and that answer is going to generate a radian that is definitely in quadrant number 4. So this is a fourth quadrant answer, and that fourth quadrant answer, x, I'll just put here, x is equal to, fourth quadrant answer is a negative radian. Now, I don't like that, neither do you, so let's add 2 pi to it and write it as its positive name, which is 5.18. There is one of your answers, okay? Now, unfortunately, that's not the only place sine can be negative. It can also be negative in the third quadrant, so we're going to get a third quadrant answer as well, too. And that reference angle that we got on the calculator that came before this right here, is the reference angle from x-axis to that value. That'll be the same thing that's added from x-axis to inside the third quadrant, and we'll have to just use it as a positive value. So we're dealing with pi adding on this value, but it's not going to be its negative partner, it's going to be the positive one. If you don't understand this part, draw a picture. It'll make a lot of difference to you. And 4.24 is going to be the other answer that's in the fourth quadrant, or third quadrant, excuse me. All right? So ultimately, 4 answers to this bad boy. 1, 2, right there, and 1, 2, right there. And those could be written with 2 pi k's on them, and so forth, okay, in terms of writing their all solutions. Wow, quadratic formula. It's a doozy, huh? The only way you're going to get decently good at doing some of these is practice. You have to try a few, and you ultimately need to ask questions about it if you get stuck. So ask your teachers in their meetings or in their personal in-person day, watch out for the quadratic formula. This is a no-joke question, and it takes a little bit of heat. All right, give it a good shot. I'll talk to you guys later when I do 5.5c.